So here's the answer to one of the homework problems from section 2.4 about the empirical rule. We're given some data here that asks the number of times men have been married. So they surveyed men and asked them how many times they've been married, and the results are shown over on the right. And you can see that most men were married never in this age range. This is age 20 to 24. 1,390 were married one time, and 24 have been married twice. So those are the only responses that we got. And so the question here is to apply the empirical rule to this data and see if it seems to work. So we don't have to put all the data into a machine of some kind. There's 8,007 data points here, so we don't want to do that. We're just going to use the summary information that they gave us. So they have already figured out that the mean answer to this question is 0.18 times married, and the standard deviation of the data collected was 0.39. And so that's using the formulas we talked about in class based on this data. But and this happens a lot in this course. When there's thousands of data points, they really don't want us having to enter them into a machine, and so they'll just give us the summary information for the data and allow us to work from that. Okay, and so the first question below says, well, the answers are already written in there, but I'll explain how they get the answers. The percentage of the observations that are within one standard deviation of the mean. And so this is very typical statistics language that we have to get used to. So within one standard deviation of the mean, the way we interpret that is you take the mean, the 0.18 is the mean, right? That's from up here, and we're going to form an interval, meaning we're going to turn this into a range of numbers that go up one standard deviation and down one standard deviation. So the standard deviation here is 0.39, and so going down one standard deviation from the mean would be subtracting, and that'll give us negative 0.21. Get by adding the standard deviation to the mean, which gives us 0.57. Okay, so within one standard deviation means between these two numbers. So what they want to know is what percentage of the observations are between negative 0.21 and positive 0.57. Well, the only number, remember these are the x values, the only one of these numbers that's between negative 0.2 and positive 0.27 is 0. So 0 is the only observation, is the only observed value that is within one standard deviation of the mean. And so this question is just what percentage of all the observations are 0. And so we can find that out by just dividing 6,593 divided by the total, 8,007. So that's the percentage, or that's proportion, of the data points that are where the answer was 0. And those are the only answers that are within one standard deviation of the mean. And so if we take that as a proportion and change it to a percentage by moving the decimal place over twice, that's where we get the 82.3%. Notice they do say round to one decimal place, and so we know that we have to take our proportion answer, move the decimal place 2 positions to make it a percentage, and then read off that answer rounded to the nearest 1 decimal place. So the next question says, what about within 2 standard deviations of the mean? And so I have to play this same game where instead of just adding and subtracting 1 standard deviation, I'm going to add and subtract 2 standard deviations. So 2 standard deviations below the mean is 0.18 minus 2 times 0.39, 2 times the standard deviation. If you do that, you get, I already did it, it's on my piece of paper, so I'm just reading it off, negative 0.6, and 2 standard deviations above the mean we get by adding to 0.18 twice 0.39, and that is 0.96. And so, once again, the only observed value that's actually between negative 0.6 and 0.96 is 0 again, right? 1 is not between those two numbers, 2 is not between those numbers. So the only observed value that is within 2 standard deviations of the mean is also 0. And so for the second question, it also can be interpreted as what percentage of the observations did we get a 0? And that's why this answer is the same as the answer before. Because 0 is the only observed value that's within 1 standard deviation of the mean, and it's also the only observed value that's within 2 standard deviations of the mean. However, within 3 standard deviations of the mean, I'll just write down the answer, I'm running out of space here, but within 3 standard deviations of the mean means between negative 0.99, that's 3 standard deviations below the mean, and 3 standard deviations above the mean is 1.35. So the observations that are between negative 0.99, oops, shoot, that's not what I meant to do. Well, I got to write over it again. Looking for that guy. So the only observed value that's between, the observed values that are between negative 0.99 and 1.35 are 0 and also 1. So both of these guys, both these observations are between these two numbers. And so this question is asking what percentage of the observation are between those two. So in other words, that's what percentage of the observations are these two guys. And so I'm just going to add these together. So the total number of observations that are between, I guess I should do that on my calculator. So the total number of observations that I have in these two categories is 7,983. So I'm just adding up the number of observations that I observed at 0 plus the number of observations where I observed at 1. And then I'm dividing that by the total number of observations, 8,007. And again, that'll give me a proportion. Move the decimal place twice and it turns into a percentage. And if you read it off, you get 99.7%. And so that's what that's how we can actually determine the number of observations or the percentage of observations that are within 1 standard deviation, 2 standard deviations, and 3 standard deviations. But that flies in the face of the empirical rule. The empirical rule, remember, says that there's a very specific number of observations, basically in this range, within 1 standard deviation, we expect 60-some% of the observations to be there, and so this is higher than we would think. And then we expect about 90-some% of the observations to be within 2 standard deviations, and so this is lower than we would think. With the empirical rule, we don't expect very many things to be within 3 standard deviations. I'm sorry, we expect almost everything to be within 3 standard deviations, and that does seem like what we're seeing here. This really is almost everything is within 3 standard deviations. And so, but these two guys are not consistent with the empirical rule. So the empirical rule says that there are only 60-some% of these within 1 and 90-something% within 2. And so this is not what the empirical rule says. And if we look at the choices, we see that the first choice is what we mean. There are more things within 1 standard deviation than the empirical rule would predict, but there are fewer things in here than the empirical rule would predict. And if we wanted to add on, we could say, and the number that are within 3 standard deviations is about right as far as the empirical rule is concerned. So the reason that the data is not consistent with the empirical rule is because it's very important with the empirical rule that the empirical rule only applies when the data is in a nice bell-shaped distribution. If you were to draw a histogram or a dot plot or something of this data, probably a dot plot's going to take forever with 8,000 points, but if we drew a picture of this, it actually doesn't look remotely bell-shaped. We have something like 6,000 values that are 0, and then only about 1,000 values, so a lot less, that are 1, and almost none that are 2. So if you looked at a picture of the data up here, it would look like this. So far from being symmetric and bell-shaped. So anyway, so this exercise is really about getting used to this vocabulary of being within 1, 2, or 3 standard deviations of the mean, but also to remind us that the empirical rule only applies to distributions where we expect that there's a symmetric bell-shaped distribution.